Let's continue with question number 10. See, on the right side we need 1. That means no trigonometric ratio. Generally when that happens, the rule is to convert everything to sine and cos. So please convert everything to sine and cos. Cosec is 1 upon sine A minus sine A. Sec is 1 upon cos A minus cos A. Tan is sine A upon cos A plus cot is cos A upon sine A. Then here we can take LCM. So here the LCM will be sine A, and here you will end up with 1 minus sine square A. Similarly here we will get LCM to be cos A, and we end up with 1 minus cos square A. And then here the LCM will be cos A times sine A, and here we will get sine square A plus cos square A. Right? So basic LCM in all the three terms. Now what does this look like? 1 minus sine square A. If you check your formula sheet, 1 minus sine square A is cos square A divided by sine A. 1 minus cos square A is sine square A divided by cos A, and here sine square A plus cos square A is 1 upon cos A times sine A. Very good, Elena. What can we cancel?
No, cos the square and cos.
Very good.
And sine.
Yeah, we can do that. So square and cos we can cut. Similarly, square and sine we can cut. After that, anything else that we can cancel, Elena?
Cos A and cos A.
Very good. Cos A and sine A and sine A. So very good. Everything got cancelled. That means we are left with 1. That is the right hand side. Question number 11. Let's see the left hand side. The left hand side we have sine, cosec, cos and sec. On the right hand side we have tan and cot. What do you suggest we do on the left hand side? See, if I open the bracket, I'll end up with cosec square, right? I can see that. If I open this bracket, I'll get cosec square. That cosec square I can convert, right, to cot square. Yes or no? Okay, let me show you the step. So this is sine square A plus cosec square A square plus B square plus 2A B. Then similarly this, if I open the bracket, what do I get? Cos square A plus sec square A plus 2 cos A sec A. This is what I was talking about. Cosec square, okay, I know that cosec square I can write it as 1 plus cot square A. Similarly, sec square I can write it as 1 plus tan square A. So see, somehow I got cot square and tan square. Now what do we do with this term? This term, if you see cosec, I can write it as 1 upon sine. So we get 2 into sine A divided by 1 upon sine A. Then similarly this also we can write 2 cos A into 1 upon cos A, because sec A is nothing but 1 upon cos A. And finally sine square plus cos square. These two are left, and we know that sine square plus cos square is nothing but 1. A lot of sine square plus cos square is 1. That's what I wrote. Cosec square I converted to 1 plus cot. Cosec I converted to 1 upon sine. Sec square I converted to 1 plus tan. And here sec I converted to 1 upon cos. What should we do on the left hand side? Who can tell me? Look at your formula chart very nicely and tell me what should we do.
So we can convert cosec to so We can convert the sec square A to 1 plus 1 square because on the right hand side tan is there.
Yes, very good. We can see that on the left side we have sec square and cosec square, but on the right side we need tan square and cot square. So there's a direct relationship. Sec square can be converted to 1 plus tan square, and cosec square can be converted to 1 plus cot square A, right? So the first rule we're using, since we already have the trigonometric ratio, means most probably we'll get the answer right. So let's multiply. I hope you know how to multiply. First with both. So 1 with 1 and 1 with cot. So 1 into 1, 1. 1 into cot, cot square A. Then second with both. So tan into 1 will give you tan square A. Then tan square into cot square. So plus tan square A times cot square A. So if you see, we already have the cot square and tan square. We don't need this, and we want a 2. I repeat, this is an extra term that we don't need, and this also kind of we don't need because we need 2 here. So these two I'll keep it preserved, right? I'll not touch it.
You can convert cot to tan.
Very good. I can convert this to tan. So I'll get tan square A times cot square is 1 upon tan square A. Why are we doing that, John?
Also cancel.
Very good. So that we can cancel and we end up with 1. 1 plus 1, 2. So cot square A plus tan square A plus 2. Which is nothing but the right hand side proved. Anyone didn't understand, please let me know. Let's see 14. 14 is very different. What do you suggest we do here? We can do what Tanisha said. Since we need sec square on the right side, I can convert everything to sec square for now. So this will be what? 1 plus 1 upon sec A divided by 1 minus 1 upon sec A. Then if you take the LCM for the denominator, LCM is sec A, and then here you get sec A minus 1. Do that for the numerator, you end up with the same thing. Sec A will be the LCM, and you get sec A plus 1. Again, your basics, we can cancel sec A and sec A, and we end up with sec A plus 1 divided by sec A minus 1. Okay, so somehow we have the right hand side. If you see, we need sec, is it sec square A minus 1? No. Okay, it's sec A minus 1, but whole thing square. We have sec A minus 1. Okay, so what do you suggest we do now? We can't just square it out of nowhere. Okay, to square it, we will need left side and right side both. Okay, but that's a good hint for others. What should we do? Okay, we will do what Tanisha said, but in a little bit different way. See, what we can do, instead of squaring, can I write it something like this? I'm going to multiply and divide by a common term, that is sec A minus 1 upon sec A minus 1. Can we do that or not? Right? Multiplying and dividing by the same term does not change anything. Yes? But it will help us a lot, because now you see in the denominator we have A minus B, A minus B. So that is A minus B whole thing square. In the numerator we have A plus B, A minus B. So that will be A square minus B square. And sec square minus 1 is nothing but tan square. So tan square A divided by sec A minus 1 whole thing square. That is the right hand side. So we have proved. So this line is important here. If anyone did not understand why we did this line, how we did this line, please ask me.
So how?
Rishabh? Yeah.
Also.
Just give me a fraction. Let's say we have a fraction 3 upon 2. Okay, imagine I multiply with a number 4 and I divide by the number 4, right? So what do we end up with? 3 fours are 12, 2 fours are 8. Now if I cancel, then what do I get? 3 fours are 12, oh sorry, 4 threes are 12, 4 twos are 8. We still end up with 3 by 2. So that does not change anything. Okay, it's something like multiplying it by 1, because anything if you multiply by 1 it does not change anything, isn't it? And multiplying by 4 means multiplying by 1. Okay. Okay. Anyone else?
We got sec A minus 1 over sec A minus 1. Can we cancel?
Now we can cancel. If you cancel, you'll end up back here again. Then again you multiply. Then again you cancel. Again you multiply. Again you cancel. No. The whole point of multiplying with the same term is so that we can write it in a different way. Got it? Okay. But that's not something what I want you to understand. That obviously you got it. My question is, did you understand why Tanisha said that we need to multiply it like this? Why? How do we know in the exam that we have to multiply? Did you get that? No. Because see, we already have sec minus 1. But what do we need? Sec minus 1 whole thing square. So if I already have sec minus 1, the only way to get sec minus 1 whole thing square is by multiplying it with sec minus 1. Yes or no? Because then sec minus 1 into sec minus 1 will give you sec minus 1 whole thing square. But I can't just multiply the denominator. I also have to multiply the numerator. Please try doing question number 15 on your own. So here I think the easiest would be to just take LCM. Okay. So if you take the LCM, what do we get? Cos A into 1 plus sine A. And here it will be this into this. So 1 plus sine into 1 plus sine will be 1 plus sine A whole thing square plus this into this. So cos square. So if you open the bracket, you get 1 plus sine square A plus 2 into 1 into sine A. This is A plus B whole thing square formula. So A square plus B square plus 2AB plus cos square A divided by, let's keep the denominators same. After that, sine square plus cos square is 1. 1 plus 1 is 2. So we get 2 plus 2 sine A divided by cos A 1 plus sine A. Then 2 1 plus sine A divided by cos A 1 plus sine A. Now we can just cut 1 plus sine 1 plus sine. 2 by cos is nothing but 2 sec A.